Ji, Bismillahirrahmanirrahim. Let's start today's lecture. Today we are starting our 7th chapter. The chapter name is waterlogging and salinity. What is its Urdu translation for this chapter?
Same
ortho. Waterlogging, same, and salinity, tho. Okay. Now, what is waterlogging? Waterlogging means rise of water table. How much rise of water table? So as far as the agricultural lands are concerned, those are called as waterlogged. When their productivity of the agricultural crops, those gets affected by the high water table. Okay, once the water table rises, then the nutrients like nitrates, which are required by the plants and crops, and which are produced by bacteria. And bacteria requires oxygen for their survival. And if there is waterlogging, it means the voids of the soil are fully filled with water. Then, and if this is within the root zone of the crops, a root zone of a plant, then what happens that there won't be much oxygen, and bacteria production would be ceased, and then nitrates will not be produced, which are required by the plants, and hence the productivity of the plants and the crops that reduces due to the waterlogging. All right. So productivity gets affected.
Yes, sir.
Yes. Do you have any questions?
No, sir.
All right. So productivity gets affected. When it gets affected, when the root zone, this is the root zone of the crops. This hole is the aeration zone, and below it there is saturation zone. The voids of the soil are fully filled with water, but this is the water table, and above the water table up to the ground surface, this is called as aeration zone, and a upper part of the aeration zone is called as the root zone of the plants or crops. So if water reaches in this zone and there is a flooding on the surface, then it means the whole root zone of the crop, the voids will be fully filled, and then it will affect the productivity of the crop, and that is called as waterlogging. Okay. So waterlogging means rise of water table such that it affects the productivity of crops. Now here you can see in this figure, this is some impermeable layer, and here this is the groundwater table, whereas this dotted line shows the depth of the root zone, and this is the natural surface. And you can see here that here the depth required is very less, so this area may be called as waterlogged area because the water table is very close to the surface. So now how the WAPDA defines the waterlogging? As per WAPDA criteria, the land having depth to water table less than 3 meters, less than 10 feet is classified as waterlogged area. So there are two classes of the waterlogged area. Number one, severely waterlogged land or waterlogged area, and number two, less severely waterlogged area. If the depth of water table is just from 0 meter to 1.5 meter, means how much? 0 to 5 feet, then that land is called severely waterlogged land. And if the depth of water table is from 1.5 meter to 3 meter, it is less severely waterlogged land. Now this table shows the picture of Pakistani land, how much is severely waterlogged and how much is less severely waterlogged. Let's see, this is the province, and here the water table depth below the surface is given in feet. So 0 to 5 feet means severely or less severely waterlogged land. क्यों जी? Severely water table depth बहुत थोड़ी है. And if it is 5 to 10 feet, less severely waterlogged land. And if it is combined, if you will 1 plus 2, then the range becomes 0 to 10 feet. And if you will see in Punjab, severely waterlogged land is 1.9 million acres, whereas 7.52 million acres is the less severely waterlogged land, and the total waterland land is 9.42 million acres, whereas in Sindh it is too much. Severely affected waterlogged land is much more than in Punjab, that is 3.13 million acres, whereas less severe is also more than Punjab, that is 8.54. So if you will see here, it is total is 11.67. So in Sindh province, what about other provinces? Very less in KP, okay, and that is total is 0.42 million acres, whereas in Balochistan the least waterlogged land is in Balochistan. There is no water, 0.38 million acres. So total waterlogged land in Pakistan is about 22 million acres. So if you will see among all provinces, the Sindh has more waterlogged area. The reason is the slopes are relatively flat, and also their water allowance is more, and they provide more water in cubics per acre, and those are the, and number third is the size of the soil particle is further smaller in Sindh part. So these are the three major reasons, and so there is an over irrigation, more over irrigation. That is the Sindh has more waterlogged land. Now, what are the causes of waterlogging? So there is a list of 8 major factors which can produce waterlogging. The most important, the first one is the over and intensive irrigation, too much irrigation. Number 2, seepage of water from adjoining highlands. And number 3, seepage of water through canals, canal network. And number 4 is the impervious obstruction. And number 5 is inadequate natural drainage. And number 6, inadequate surface drainage. And number 7 is the excessive rainfall. And number 8, irregular or flat topography. So these are being discussed in the next slides. Let us discuss the over and intensive irrigation. You know, if there is over irrigation, if we are supplying too much water to the agricultural lands, you know, that much water is not required by the root zone of the crops. And what happens that due to watering through flooding, so that infiltrates into the lower layers, and ultimately continuous that irrigation or watering, that water goes and joins the water table, and the water table rises. So the major cause of you know, this is an artificial reason, man-made reason, due to which the water table rises. So over irrigation. So, you know, that's why whenever we provide irrigation projects, So in an irrigation project, we also keep the provision of drainage project. So irrigation and drainage, so they are very compulsory, because artificially you are supplying more water to the lands, which was not a natural phenomena. So definitely that has to rise the water table. So you need also drainage, as that excess water should be drained somewhere. So second is the seepage of water from adjoining highlands, and suppose you know, this is a hill slope like this, and there is a flat land here. So whenever there would be rainfalls, the water from this area will come here and stay here for a long time. Okay, and that will infiltrate. Continuous rainfalls for so many days, it will cause infiltration, and then finally it will raise the water table. That the third is seepage of water through canals. So the canal network is huge. There are many main canals maybe, and then from one main canal there are many branch canals. From one branch canal there may be many distributaries and miners, etc. So there is a network of the canal, and if it is not lined, then there would be a lot of seepage. And in Pakistan there is about 9,200 kilometers is the length of the canal network. The next reason of the waterlogging could be impervious obstruction. If there is an impervious obstruction below the surface of the earth, some impermeable layer, so then the infiltration capacity, or the water cannot go down further. So the volume carrying capacity of the soil above the impermeable layer is lesser, and that's why rapidly it increases the water table and causes the waterlogging. The next is inadequate natural drainage. Natural drainage means, of course, the both type of the drainages, particularly if the soil permeability is very less, then what happens? Of course, water cannot move fastly into the ground, and then it appears on the surface. That because waterlogging. On the other hand, if the soil is much pervious, then it can go down into the and causes the high water table. The next is inadequate surface drainage. If the surface drainage is not there, and whenever there is a rainfall and the surface water stays over the land surface, then of course eventually it has to infiltrate into the ground, and that raises the water table. The next is excessive rainfall. Whenever there is excessive rainfall, maybe very, very long durations. If there is no natural surface drainage and subsurface drainage, then of course it has to rise the water table, and then it causes the waterlogging. Number 8 is irregular or flat topography. As we discussed, in the sin, most of the part is flat, and in flat lands, as there are no surface drainage better, so the water table rises, and it causes the water logging. Now the next topic is effect of water logging. What are the consequences of water logging? So water logging, number 1 is it kills the bacteria which produces nutrients. All right. So second is, once the nutrients are not produced, so what will happen to the crop yield? So there is a loss in crop yield. The third is waterlogging leads to salinity. So the waterlogged soils, after some time, they become saline soils. And the major reason of the waterlogging basically is the over irrigation or irrigation without drainage. The next is normal cultivation operations cannot be carried out easily in the wet soil. The plowing, the other things is difficult. And the next is certain water loving plants, they grow like, the grasses and weeds and they affect the growth of the crop. And the next is spread of mosquitoes in the moist environment. And the next is destruction of the roads due to reduced bearing capacity of the subgrade material, and also causes dampness in the buildings if there is waterlogged land, and the appearance of salt on the surface. There would be salt on the surface. It means the soil will become saline or salty soils, and which weakens the plaster and produces ugly spots on the buildings. And the next effect of waterlogging, if the salty soil is used to make bricks, the salt appears on the wall surface. So these are the effects. Now, what are the remedial measures of waterlogging? There is a list of remedial measures. Number one, provision of efficient drainage system. That's very necessary. Number one. Okay. So without efficient drainage system, irrigation itself is not advisable. So whenever we provide irrigation, we design irrigation projects. So beside it, we also design drainage projects. So irrigation and drainage, they are compulsory for each other. And the next is lining of canals and water courses. So with that, we can reduce waterlogging. The next is reducing the intensity of irrigation. Intensity means too much supplying water to the crops. If we reduce it, then we can control this waterlogging by introducing crop rotation. Okay, and the next is by optimum use of water, and the next is providing intercepting drains and improving natural drainage of the area. And the eighth is introducing to lift irrigation. Now these we will discuss all here. Provision of efficient drainage system. So we have to provide good horizontal drainage system. If we are providing an irrigation system, so beside it, we must provide a good horizontal drainage system. And horizontal drainage system means the surface drainage system and subsurface drainage system. Subsurface drainage is also called as tile drainage system. Number two, lining of canals. So lining of canal system, of course, reduces the seepage to the soils, and then we can reduce the waterlogging. The third is reducing the intensity of irrigation. So intensity of irrigation should be reduced as far as possible. And once the intensity of irrigation is reduced, then waterlogging we can control. And number four, by introducing crop rotation. So certain crops, they require more water. So those crops should not be repeated again and again, because once you will supply more water to the lands, it will infiltrate more and that will rise the water table. So there should be crop rotation. After a crop which requires more water we have grown, then the next should be a crop which requires less water. Optimum use of water. So that too much water, by the way, is not required by the crops. So if you plot a graph between the between the efficiency or the crop yield. So this is the crop yield and the water quantity. Then you will get maybe a graph like that. So it shows that only this much quantity will produce the maximum crop yield. And even if you will increase the water, it will reduce the crop yield, or if you will reduce the quantity of water further, it will reduce the crop yield. So don't provide water more than the optimum value. Okay, that is useless. The next, number 6, is providing intercepting drains. You know, in as we discussed that if there is a hilly area and then there is a flat land, so better to provide here is an intercepting drain. So whatever the runoff it will come, that will flow to this intercepting drain and will not affect the level land. So in this way we can, so it's a better drainage basically. Number 7, improving natural drainage of area. So to reduce percolation of water, the water should not stand for longer period. So the natural drainage should be such that it should move. And introducing lift irrigation. Lift irrigation means by using tube wells. So what the tube wells do, they extract groundwater, and then that water is being used maybe for irrigation for other purposes, or even for lowering the water table and then discharging into the drains. So this is called as vertical drainage. So pumping water or lift irrigation is called as vertical drainage, and surface and subsurface drainage is called as horizontal drainage. Okay, so these are the various remedial measures by which you can reduce the water logging. So here in this figure, so there is a Dutch windmills, so these one, which are pumping water from waterlogged soils. Okay, and they are throwing in this the channel. The next is the land drainage, because the drainage is very, very important, particularly horizontal drainage. So whenever we are designing, we are planning and designing and constructing the irrigation project, beside it, we must also plan, design and construct a drainage project. So irrigated area requires 2 types of the drainages. Number 1, surface drainage, and number 2, subsurface drainage or tile drainage. Okay, so both we have to provide. We will discuss first the surface drainage. So what is the surface drainage? So through surface drainage, what we have to do, we have to provide some slopes proper on the surface, and the water should move towards the drains which we have provided. There may be some shallow drains. The water from the land goes into shallow drains, and then these shallow drains water, then it is discharged into the deep drains. And like that, this is the surface drainage. So the same is mentioned here. Surface drainage is the removal of excess water by using and construction open ditches. Open ditches हैं इसमें, field drains हैं, and land grading है. Grading means providing by proper slope and making some relevant structures. Open drains which are used to remove water from excess irrigation or excess irrigated area, and also storm water means rainfall, are broad and called shallow surface drains. Okay, so land grading include continuous land slopes towards the field drains. Shallow surface drains are trapezoidal in shape. It has a trapezoidal cross section and constructed to carry normal storm water, these convey water to deep surface drains. So there are shallow drains and deep drains. Both they have the cross section trapezoidal. So deep surface drain are constructed to carry storm water plus excess irrigated water from shallow or tile drains. Shallow drains and also tile drains means that is the subsurface drains. Okay. So here there is a cross section of a canal and of the drains. So upper one is the cross section of a canal. Now let's see what are the differences. By the way, what we call to this drain in Urdu? What we call?
सर खालियां खालियां सर
क्या?
खालियां सर
What? Khaliyan. You want to say khala in Punjabi?
Yes sir.
No, khala is irrigation channel. Khala is not a drainage channel. Okay. Actually, you know, the drainage word which we used in the previous chapter, which was the cross drainage structure, that was different. And here once we say drain, it is different. वो drain हमने किस लिए कही थी? Drain जो in the previous cross drainage books, that was for rivers, streams and rivers. अब हम drain किसको कह रहे हैं? अच्छा, and what we call this canal in Urdu, by the way? कैनाल को उर्दू में क्या कहते हैं?
नहर
नहर नहर नहर ओके गुड. एंड यू नो ये जो ड्रेन है इसको हम उर्दू में क्या कहते हैं? वी कॉल इट सेम नाला. हैव यू हर्ड?
Yes sir.
Have you heard earlier? Huh? So that is the same nala. So same nala is different as compared to natural rivers and streams. Now, what is the difference between canal and drain? This drain, which we use for the surface drainage. So, you know, the first difference is that where, by the way, do we like to align a canal? On the, कहाँ रखेंगे canal को? On the ridges, है ना? The canal is always aligned, and it is tried to be aligned along the ridge lines or along the peaks in the area. Whereas where do we provide this drain? Drain हम कहाँ बनाएंगे? Peak पे या valley में?
Valley में.
It should be in the valley, ताकि surface water खुद ही gravity से उसमें जाए, है ना? This is one difference. What is the second difference? This is the full supply level of the canal. By the way, where do we keep full supply level of the canal? Above the natural ground or below the natural ground? NSL से ऊपर रखते हैं, नीचे रखते हैं?
Above the natural ground.
Why? To have gravity flow, है ना? पानी लेना है ना हमने कैनाल से. What about the full supply level of the drain? Do we keep above the natural surface or below the natural surface?
Below sir.
Below. कितने फर्क हो गए? 2, है ना? What is the use of canal? They supply water to the adjoining lands for irrigation purpose. What is the purpose of the drain? To receive water, surface water as well as subsurface water into this drain. What is the purpose? We want to lower down this water table. Now this is the groundwater table. Okay. So due to this drain, ये पहले हो सकता है अगर if we have not provided this one, ये ड्रेन अगर ना प्रोवाइड करते तो हो सकता है वाटर टेबल यहाँ होती, बट ड्यू टू दिस ड्रेन so water table has been lowered और ये पानी यहाँ पे ड्रेन हो गया, and you can see the shape of the water table. Okay, so that is the use of the drain. Alright. So canal is used to supply water to the lands, whereas drain is used to escape water, to discharge water from the lands. तो कैनाल का वाटर क्या करता है? वाटर टेबल को ऊपर करता है, नीचे करता है?
ऊपर करता है.
Yes, it rises the water table. और ये ड्रेनेज का क्या पर्पस है? वाटर टेबल को वापस नीचे कर रहा है, क्योंकि हमने आर्टिफिशियल कैनाल बनाई और उससे वाटर टेबल ऊपर गई. तो by providing a drainage network, we can lower down it. Anyway, this is the surface drains. These are the surface drains. Now we have to discuss the subsurface drainage system. Yes.
The drainage system जो है वो water को drain कहाँ पे करता है at the end?
Yes, this is a very good question. Of course, ये हमने डिस्कस किया है कि ये पहले होंगी शैलो ड्रेन्स, है ना. शैलो ड्रेन्स जो हैं वो डायरेक्ट पानी कहाँ से ले रही हैं? फ्रॉम दी लैंड सरफेस. तो इसमें जो पानी यहाँ आ जाएगा, फिर अंडरग्राउंड से भी पानी इसमें आएगा. नाउ दीज शैलो ड्रेन्स विल डिस्चार्ज वाटर इनटू, किस में पानी डालेंगी? डीप ड्रेन्स में. वो भी ओपन ड्रेन्स हैं. दे हैव आल्सो द ट्रेपेजॉइडल सेक्शन. वो जो डीप ड्रेन्स हैं, देन दे विल सप्लाई वाटर टू द रिवर. जो नेचुरल रिवर्स चल रहे हैं उसमें वापस फेंक देंगे एट ए सम लोअर लोकेशन. ठीक है जी.
सर लेकिन ड्रेनेज सिस्टम में जो वाटर होगा उसमें फर्टिलाइजर्स वगैरह भी तो वॉश अप होगा ना उनके काफी, तो उससे पोल्यूशन वगैरह नहीं होता है रिवर्स में?
सॉरी
सर, जो ड्रेनेज सिस्टम का वाटर होगा उसमें सिर्फ फर्टिलाइजर्स का वॉश ऑफ भी तो काफी ज्यादा होगा, कंसंट्रेशन ज्यादा होगा.
देयर वुड बी वॉश आउट ऑफ फर्टिलाइजर्स होगा, इसमें कोई शक नहीं है. देयर मे बी मोर सैलिनिटी, सेलाइन पानी हो सकता है अगर तो द सॉइल इज सेलाइन है उसमें, तो वो भी निकलेगा. तो डेफिनेटली सो क्या करना चाहिए? व्हाट डू यू रिकमेंड? Of course, water we have to discharge into the rivers, but without treating or after treating?
After treatment.
After treating. So it means if the water quality is not acceptable as per कौन से होते हैं? WHO standards होते हैं. WHO, World Health Organization, है ना. स्टैंडर्ड्स अगर उससे ख़राब हैं आपके पैरामीटर्स, तो देन द वाटर मस्ट बी फर्स्ट ट्रीटेड एंड देन इट इज थ्रोन इनटू द रिवर. नाउ वी हैव टू डिस्कस द सबसरफेस ड्रेनेज. सबसरफेस ड्रेनेज का दूसरा क्या नाम है? टाइल ड्रेनेज. सो सबसरफेस ड्रेन्स आर रिक्वायर्ड. पहले होती क्या है? सबसरफेस ड्रेनेज बेसिकली पाइप ड्रेनेज है. टाइल ड्रेनेज का मतलब है पाइप ड्रेनेज. पाइप्स हम प्रोवाइड करते हैं बिलो द सरफेस ऑफ अर्थ विद ओपन जॉइंट्स एंड देयर इज अ फिल्टर मटेरियल अराउंड द जॉइंट. सो तो पानी जो है वो क्या होता है? वाटर देन एंटर्स थ्रू द जॉइंट्स एंड देन इट मूव्स इन सम डायरेक्शन. तो वो जो लेटरल पाइप हैं, फ्रॉम दैट द वाटर एंटर्स इनटू द मेन पाइप और मेन टाइल ड्रेन, and then from the main tile drain it is then discharged into the deep open drain. Okay, so what is the use of the subsurface drainage? ये basically वो soils with poor internal drainage, जिनमें ड्रेनेज यानी परमेबिलिटी बहुत कम है उन सॉइल्स में. सो और वाटर टेबल ऊंची हुई है, तो there we can use subsurface drainage or tile drainage system. So tile drains are basically pipe drains. पाइप की हैं, made up of porous material या porous material है, या they have open joints. Diameter इनका रेंज कर रहा है from 10 to 30 centimeter. 10 सेंटीमीटर का क्या मतलब है? 4 इंच से 12 इंच, 1 फुट. Okay, so these drains laid below ground level, ground level के नीचे लगाते हैं, connected with each other by open joints. तो open joint होते हैं ताकि पानी वहाँ से अंदर जाए. So construction of subsurface drainage is given below. इनके ये component है. Number 1 is the envelope filter, and then the outlet for tile drainage. These two things we will discuss. तो envelope filter क्या है? So we have कोई भी trench खोद के उसके अंदर हम porous material fill करते हैं, like sand है या gravels हैं. तो as the filter should form, as only the water should enter into the tile drain and no soil particles should not enter. उसके लिए हमें we have to give the filter. So the same we have discussed, and one more way in the tile drainage. This is the tile drain. Okay, pipe बन लगा हुआ है नीचे at this depth of the and you know this soil is highly impermeable. तो what do you think, जो पानी है वो यहाँ से इन्फिल्ट्रेट तो बहुत मुश्किल से करेगा ना, या करेगा? Very difficult कि ये इन्फिल्ट्रेट करे यहाँ से. If it is highly impermeable soil, so then what we have to do, we have to give inlets. Okay, so these are the surface inlets. So this is a surface inlet. ये वाला surface inlet है, and here we provide some in what ये filter provide करते हैं. Filter material means gravel, sand, etc. And तो ये थोड़ा low lying area इसका depression दे देते हैं. As the surface water should come here, and from that water, you know, after filtering, there is a vertical pipe which is called as inlet, surface inlet, and then it supplies water to the tile drain, and then the water moves in some particular direction where the slope is given. So this is also inlet, one more inlet, in which just there is a filter material is provided, and the water in this way goes to this drain. This is called as tile drain. So again, these are the figures in which there is some material, a filter material, and here, and the water from the surface comes like that, and it lowers the water table. The same is the case in this figure. Now we have to discuss the outlets of tile drains. अब ये जो टाइल ड्रेन है, पाइपलाइन है, इसका कहीं आउटलेट भी तो होगा, ठीक है ना? तो जो मेन टाइल ड्रेन है, इट इज यस
सर, एक स्टूडेंट अभी मैं वेट कर रहा हूँ, उसको अटेंड करना वेट
कर रहा है. Meeting in lobby 48. Okay. तो कंटिन्यू करें. Where is that? Yeah. तो जो वाटर है फ्रॉम मेन टाइल ड्रेन, मेन जो टाइल ड्रेन होगी, एक है लेटरल टाइल ड्रेन्स. लेटरल टाइल ड्रेन्स दे सप्लाई वाटर टू द मेन टाइल ड्रेन. टाइल ड्रेन मतलब पाइप है बिलो द सरफेस विद ओपन जॉइंट्स. और वो जो मेन टाइल ड्रेन है, दैट इट हैज टू डिस्चार्ज वाटर ईदर बाय ग्रेविटी और बाय पंपिंग. दो सूरतें हैं. A है gravity outlet. If by gravity the outlet is called as gravity outlet, but if the pumping is required to discharge the main tile drain water into the main deep drain, then that is pump outlet. So these are the figures, and that we would like to understand. ये पहली figure है gravity outlet for the tile drain. तो ये टाइल ड्रेन आ रही है. दिस इज द टाइल ड्रेन. दिस वन इज द टाइल ड्रेन व्हिच इज द मेन टाइल ड्रेन व्हिच इज कमिंग, और ये दिस इज कॉल्ड एज आउटफॉल. ओके, जहां से ये पानी बाहर आएगा, डिस्चार्ज होगा, एंड दिस इज कॉल्ड एज इनवर्ट लेवल ऑफ द टाइल ड्रेन, एंड दिस इज कॉल्ड एज क्राउन लेवल ऑफ द टाइल ड्रेन. If the invert level of the tile drain at the point of outfall is higher than the full supply level of the outlet drain, then we have to provide a gravity outlet like this. So the water will flow through gravity. But if this is not possible, okay, and the inward level of this tile drain, main tile drain, is lower than the full supply level, which is here, and it is much below, then by gravity it is not possible, because the full supply level is higher as compared to inward level of the main tile drain. So then what we have to do, we have to provide here a wet well, and the water should first enter in this well, and this is the this level is the pump start level. Automatically pump starts, then the water level goes down, and when the water level reaches to this level, this is the pump stop level. So it automatically stops unless the more water comes from here. And pumps is when the pump is started, the water flows through the pump and is being discharged into the main open drain. So this is called as basically pump outlet. Is it clear?
Yes, sir.
Okay, now the very important topic, what should be the spacing of the tile drains? कितनी दूर दूर लगानी चाहिए? This is tile drain. These are tile drains. And due to these tile drains, what is this dotted line? This is the water table. Okay. ये water table नीचे आ गई है. हो सकता है पहले water table यहाँ हो. Maybe at this location. The original water table was here. And we have provided this tile drain. What is the purpose? To lower down the water table. अब water table कहाँ आ गई? अब water table is here. Okay. So it means it is lower down. So the spacing, usual spacing of the tile drain is from 50 to 150 feet. 50 से 150 feet we keep the spacing of the lateral tile drains. But we can also calculate by this formula, okay, where capital L is the spacing of tile drains, where A, suppose this is some impermeable layer in the agricultural land. This is the free surface, and this small a is the vertical distance from this impermeable layer to the center of the drain, and this B is the vertical distance from this impermeable layer to the apex of the water table. And if you know the A, you may add few feet in it to determine the value of B approximately, and maybe you may use 1 foot to be added. So this is the equation to compute the spacing of tile drains, which is the 4K B square minus A square over Q, where Q is the discharge which is going in these tile drains, and K is the hydraulic conductivity of this porous medium, and B and A I have already explained to you. These are vertical distances, and L is the spacing of tile drain. So we can use this formula. Now we have one numerical, and first we would like to understand this numerical. This is example 12.1 of our book. He says that a farmer plans the installation of tile drains in a field in which the soil permeability is 500 gallons per day per square feet area. Okay, so this is the value of K, and an impermeable stratum exists about 10 feet below the soil surface. So this total distance is 10 feet, and this is an impermeable surface. And the groundwater level is desired at least 3 feet below the soil surface. Now what he wants, that the farmer wants, that this water table should be should go at least 3 feet below the soil surface. So if it is 3 feet below the soil surface, what should be the value of B? If this total is 10, क्यों जी?
7 feet.
हाँ जी?
7 feet.
7 feet. So the value of B is 7 feet. And how much should be the value of A? Roughly you have to subtract 1 foot. So it should be A is 6 feet. है ना? So what the farmer wanted, actually the water table was much closer to the soil surface. Maybe 1 feet or even less than 1 feet. The water table was here. So he wanted to drop this water table to 3 feet. So it means this distance he wanted 3 feet. So that's how he has achieved, by providing tile drainage system. And expected discharge to rain or otherwise is 0.05 cubic foot per hour per square feet. Now this is the solution. This is the equation for L. A and B values we have already learned how to be computed. The value of K is 500, and what is 0.13? That is the relationship between gallons per day. 1 gallon per day is equal to 0.134 cubic feet per day. So if when we multiply it, we got these units. So cubic feet per day per square feet. Now the value of the K, then finally it came 2.79 feet per hour. If you convert these units, this is cubic feet, this is square feet. And then the discharge, which is the total discharge, it is 0.05, which is given here, cubic feet per hour into feet. So per feet square. So if you multiply by the L, so this will become, instead of area, it will become length, or 0.05 L cubic feet per hour. So now we have this value of the Q. So just put in this equation, and then you will get the value of L, which is 53.8 feet, or you can say that roughly the spacing should be 55 feet. Okay, so this is the answer, how you have designed the spacing of the tile drainage. So now we have to discuss the layout of tile drainage, or shall we take rest, some rest, maybe 5-minute rest?
Yes, sir.
Okay, just take today 5-minute rest because we want to complete both chapters. The other next is very small chapter, huh?
Okay, sir.
All right. Okay, shall we continue? So are you back from break?
Yes, sir.
Okay. So now we want to discuss several layouts of the tile drainage. Tile drainage means subsurface drainage, which we provide. What are the possible layouts? These layout mainly they depend on the topography of the area. Okay, like a canal is given going like that, and these are the two distributaries, and then we have provided like these lateral drains. Lateral drains कौन सी हैं? Tile drains हैं. Yes. With the 1/7 session. Excuse me. Graduated with the 1/6 session. But you know who stopped my this man, Dr. Habib? How you stop you? He told you that you are still young? No, he said it's close. It's close. Sure. Yeah, it's close. What's wrong, man? 202.
Yes, sir.
What?
Sorry, sir.
What do you want to say?
Nothing. I forget the mic open, sorry.
Okay.
Sorry, sir.
No problem. So these are the lateral tile drains, means the subsurface drains. These are pipes with open joints, and these lateral drains, they drain water into the main drain. This is the main pipe drain or main tile drain, and this main tile drain discharges in the surface drain. So this is a surface drain, and this surface drain again discharges into the main deep surface drain. So anyway, the various layouts of the tile drain, they are, you can say maybe these five. Number one is the natural system. Let us discuss this natural system. If you see these dotted lines, what is shown in the dotted lines of the area?
Contours, sir.
Contours. These are the contours. So what these contours shows, where you find such type of curves. So these type of curves either show the peaks in the area or valleys in the area. Okay, always remember that. If you see such type of bends in contour map, तो वो क्या शो करते हैं? या तो peaks होंगी या valleys होंगी. But here what are these? Are these valleys or peaks? So it means this is peak or valley. How you can know that? Just check the elevation here and here. So here elevation is 222 feet, and here elevation is roughly how much? 220. It means this side is lower as compared to this. So it means this is a valley. Okay, so this is a valley. If it is opposite to it, this is then is a peak. So these are the valleys in the area like that. So these are the valleys. So if you are providing a tile drainage in the valleys, so this is called as natural system. Okay, so of course the surface water is also moving like that, and the subsurface water, for subsurface water you are providing these laterals, and their directions are also along the valley, and this is the main tile drain. So this system is natural system. So natural system means the system which we provide on the basis of the topography is called as natural system. Now the next is grid iron system. Now in the grid iron system, this is the main tile drain, and these are the lateral tile drains, and you see that the lateral tile drains are only provided on one side of the main, not on this side. So in this system, laterals are provided only on one side of the main tile drain. It is adopted when land is practically level. So if this land is more or less level, if you see these levels, so these are light, but in this direction the land is leveled. Herringbone system. Again, you will see that these contours, these are the contours, and what this shows. This is contour of 222, this is the contour of 220. So it means this is again a valley, and the main tile drain is provided along the valley, and the laterals are provided alternately from left and right, from right and left, and these alternately are provided. Such a fashion of the tile drainage is called as herringbone system because it resembles with the bone of the fish. Double main system. Double main system means there are two mains or main tile drains. One this and another is this. So each main tile drain receives lateral drains from one side, and it receives from the one side. And if you will see, these are the contours. So again, there are peaks here, the curves. So it shows what is this location where we have provided two mains. Actually, this is again a depression. All right. So this is a valley. So this hole is a valley, but this valley is very wide. Why we have provided two mains? Because the valley is wider. All right. So this is called as double main system. Now intercepting tile drain. Now this one is the intercepting tile drain. This is a hill slope. You can see that this is 224, this is 222, this is 220, this is 218 like that, and this is even lesser than 218. So it means this is hill slope. So there is a hill slope like that. And a tile drain we have provided here, which intercepts the water of this hill from the hill slope and does not allow to move further in downstream direction or in this area. Okay, so that is the function of intercepting tile drain. Now the next topic is salinity. Salinity, what we call in Urdu to salinity?
Thor.
Yes, Thor. So what is salinity basically? It is the concentration of dissolved salts found in water. Okay. And what is its measure? Total amount dissolved salts in parts per thousand or parts per million. Huh? But parts per thousand is a standard unit, and it is also called PSU. Practical salinity units, PSU. 10 PSU means 1% salts. Okay. What are the injurious salts for the agricultural lands? Those are alkali salts. What are their examples? These are the examples. Sodium chloride, sodium sulfate, and sodium carbonate. What is sodium chloride? ये क्या चीज है?
सर साठ जो हम घरों में भी यूज करते हैं.
Yeah, this is the salt which we eat. And what is this sodium carbonate? Dobi soda?
Yes, sir.
Which we use for washing cloths, etc. This sodium carbonate is most harmful salt, and the sodium chloride is least harmful. So these salts are soluble in water. ये solve हो जाते हैं ना water में. In soils, salt moves with water. Soils में पानी कैसे salt कैसे जाता है? Through water. So in waterlogged soils, जिसमें water logging है तो water table ऊपर आ गई है. So salt appears on the surface with water due to capillary action. How the salts move on the surface? Due to capillary action. Water table is very close to the ground surface, and then there is capillary action, and through that capillary action further water moves up and comes on the surface. Water gets evaporated but leaving the layer of the salts. How much thickness? Maybe 5 to 7.5 centimeter thickness of the salts on the surface. That thickness of the salt on the surface is called as efflorescence, like this. Have you seen such type of the efflorescence on the lands? देखा है भाई कभी?
Yes, sir. Yes, sir.
Have you seen such type of lands? You can see that very thick surface of efflorescence, है ना? So this is called as efflorescence. What is the primary man-made cause of salinity? The answer is over irrigation. बहुत ज़्यादा पानी डालेंगे. And irrigation without drainage. Irrigation without drainage will result in waterlogging and result in salinity. River water or groundwater used in irrigation may also contain salts, which remain in the soil after water has been evaporated. So that is due to over irrigation. And this is the saline seepage area. So suppose here we have in any area there are more salts and there is rainfall. So now when the water will infiltrate and will move in this direction, it will the many salts will get dissolved in water and they will appear here. And this is the saline seepage area. It will become, हाँ. और यहाँ पे क्या होगा? After some time, when the water will get evaporated, तो यहाँ पे क्या बनेगा? Efflorescence. You will see the efflorescence, white layer of salts. Now the salinity control. What we can do? How we can control the salinity? There are only two, and that is also called as soil reclamation. Where is that? किधर चला गया? Yeah, this is soil reclamation. Is also called as soil improvement. How we have to do soil reclamation or soil improvement? Yeah, this is also called as a rehabilitation of the soil or remediation or recuperation. That means all they have the same meaning. Okay, means to make a soil usable for agriculture, soil reclamation. So there are two main approaches to do that. What are those? Number one, first provide efficient drainage, and second, we can do leaching. Okay, so if we want to control water logging and salinity, what we have to do? We have to provide efficient drainage, and then we have to do the leaching if the soil has changed into saline soil. What is the leaching? So it is a primary method of controlling soil salinity. What is that? We permit about 10 to 20% of irrigation water to pass through the soil, to leach through the soil, be drained and discharged through an appropriate drainage system. पानी ऊपर से आएगा, leach करेगा, and in the soil, pass करेगा through the soil, और नीचे subsurface drainage से it will be discharged. Okay, and in the diagram, suppose, where is that? Yeah, if this is the ground surface, and these are the tile drains which we have provided. So the due to that, water table will, suppose the water table originally was here, now it will go down here, number one. Number two, when we will do the irrigation, so the irrigation water will be discharged through this pipe or tile drain, and this soil will be leached. Okay, and as this water, which is irrigation water, its salt concentration is lesser, and as compared to the water which is being discharged from the soil, its salt concentration is 5 to 10 times higher. So the salt content from this soil, those are removed or reduced up to some extent. When sodium carbonate is present in saline soil, we may add gypsum in water and for the leaching purpose. It makes sodium carbonate reacts with calcium sulfate, and which forms the sodium sulfate, which can be leached out easily. So this is how we can do the leaching. So that is the. Have you ever heard SCARP? SCARP का नाम सुना है? SCARP was a department made for salinity control and reclamation project. SCARP. Okay, so what they did, they provided the drainage, surface drainage and subsurface drainage for agricultural areas where the irrigation was provided, and then they also have managed the leaching, and through these two processes, efficient drainage and leaching, they reclaimed certain area of waterlogged and saline soils. And with this, we have finished this chapter. If you have any questions, you are welcome. Yes.
Excuse me,
Ji.
sir, we have modern techniques to reclaimate the soil.
Yes, actually, these are the techniques. The first is provide efficient drainage. There is nothing we can say the modern. If the drainage is not there, the water will stay, the water table will rise, and of course the salts which are in water, those will appear on the surface. And secondly, first you provide the drainage, surface and subsurface drainage, and then you do the leaching. In leaching, you may use some chemicals, more chemicals like calcium sulfate and others. वो उस पर research हो रही है, and we may find certain more chemicals which we can mix in water for leaching purpose. लेकिन leaching ही करनी पड़ेगी. Leaching means passing water through the soil, ताकि जो इनकमिंग साल्ट कंसंट्रेशन है वो कम है, और आउटगोइंग जब वो ज़्यादा हो जाएगी तो डेफिनेटली द साल्ट्स विल बी रिमूव्ड, सम ऑफ द साल्ट्स विल बी रिमूव्ड फ्रॉम द सॉइल. ओके, डू यू हैव सम मोर क्वेश्चंस?
सर आपके लैपटॉप की चार्जिंग पूरी हो गई है.
मैंने उतार दी है बैटरी, वो पावर. All right, Jay, now let us start the last chapter, which is a very small chapter. And we would like to cover only the theoretical part of this chapter, because its understanding is very useful for you, and that is the design of wells. For irrigation purpose, how we can extract groundwater? Groundwater can be extracted by three sources, either by providing wells. Those wells could be open wells or deep wells. Okay. The secondly, we can get groundwater through springs. Springs को क्या कहते हैं in Urdu? Springs. चश्मा. चश्मा क्या होता है? जब ग्राउंड वाटर टेबल जो है कट करती है टू दी नेचुरल सरफेस, तो वहां से पानी बाहर निकल आता है ना? तो दैट इज कॉल्ड एज, नॉर्मल ये चश्मे कहाँ होते हैं? एट द फुट ऑफ माउंटेन्स, है ना? उसके अंदर पानी भरा होता है, इनफिल्ट्रेट हुआ होता है वाटर, तो सॉइल के अंदर पानी होता है, और अगर नीचे से वाटर टेबल कहीं कट हो गई है तो वहाँ से पानी निकलेगा, तो उसको हम चश्मा कहते हैं। द नेक्स्ट इज कारेस। So I think the people from Balochistan, they know very well. It is also called as kanat or kanet, and these kares are actually, these were practiced much more in Balochistan, Iran and Afghanistan. And what is a kares? Is basically a tunnel. This is like this tunnel in soft formation in the foot hill. Actually यहाँ पे hill है बहुत बड़ी है, ये hill का foot है, तो यहाँ से वो क्या करते थे कि यहाँ these are the vertical shafts, so they were making a tunnel like this, vertical shaft बनाते थे और आगे connect करते जाते थे, and then this was the water table. तो यहाँ पर ये tunnel water table के नीचे आ गया। जब ये नीचे आ गया तो वाटर टेबल से पानी इस टनल में आएगा, एंड इट वुड बी डिस्चार्ज फ्रॉम हियर, वेरी सिमिलर एज देयर इज अ डिस्चार्ज फ्रॉम ट्यूबवेल, एंड they were supplying, and they are supplying water to agricultural lands. So this is the concept of kares. Is there anyone from Balochistan? Someone from Balochistan, can you explain us the kares? No one. Anyway, this is the how.
मिनट नहीं होता।
हाँ जी, सॉरी, आवाज तो
मैं कह रहा हूँ
यस यस प्लीज। बताएं यार कुछ। अच्छा, nobody is from Balochistan. All right, now we have to discuss the wells, open wells and deep wells. What is open well? How? Hand dug wells in shallow water table. So ये shallow water table available है, maybe 25-30 foot पे, and then it is 8 to 10 feet diameter hole we make. We dig this well, and this is the masonry wall with open joints, as the water should come inside, and the bottom is plugged with the not plugged, but actually big stones or gravels are thrown here to avoid the boiling of the soil. And let's say due to the continuous taking water from the well, the water table has lowered down. Originally water table was this, and this is the cone of depression. But anyway, this is the open well, and these are hand dug wells, and their diameters is up to 10 feet, and the depth maybe we can provide up to 100 feet, and it has a very low discharge. So these are the open wells, and I think most of you have already seen these open wells. So these are used to extract ground water. Some may install Persian wheels previously. Nowadays we install pumps to take the groundwater. What are the deep wells? Wells penetrating in deep aquifers, and they are machine bored. Very deep, water is extracted from deep aquifers. Like in UET Lahore, the two wells which are installed they are extracting water from 650 feet. So those wells are deep wells, all right, and can be drilled in solid rocks. For example, if it is hilly area, or in sandstone, like sandstone or limestone, or when drilled in alluvium, like in Lahore, they are provided with a screen. So this is a deep well which is provided in the hard stratum, and this is a deep well which is provided in the soft stratum, and we provide here a screen is provided, the pipe with openings as the water should enter. These deep wells are of small diameter, less than 12 inches. 12 इंच से कम डाया होता है, और इसका डाया जो है 10 फुट से तकरीबन 10 फुट या इससे कम, and can produce high discharge. ये deep well से हम ज़्यादा discharge ले सकते हैं, maybe up to 2.5 cusecs. So there is here is a well, tube well, and you can see the water coming from the tube well to supply water to agricultural lands. Which type of well it is? Deep well or shallow well? क्यों जी? Open well है या deep well है?
Deep well.
Deep well. Now types of flow or aquifer through wells. These four are the types which we have studied. Only the two we will just very quickly go through these. Steady unconfined aquifer, we know unconfined aquifer and confined aquifer. अगर उसमें flow steady होगा तो वो flow कौन सा कहलाएगा? Steady flow in unconfined aquifer and steady flow in confined aquifer. Similarly, flow कौन सा हो सकता है? या unsteady हो सकता है in unconfined aquifer and unsteady in confined aquifer. So these two type of flows, ये दो flows जो हैं यहाँ पे, पहले steady flow in unconfined aquifer, and these all equations you have already developed, I think, in geotechnical engineering. Main equation जो है derivation की वो क्या है? That is Darcy law, discharge is equal to KIA, and finally you get this equation. तो discharge ये pump से जो निकल रहा है, well से जो निकल रहा है, वो है 2.72. T is the transmissivity, H minus HW. H is this one, and which is the thickness of aquifer, and HW is basically this one after drawdown, and yeah, this is the high head at well, and R is the radius of influence, and RW is the radius of well, and this is the equation. And steady flow in confined aquifer has this equation, okay, 2.72 H minus HW log of 10 R over RW. So we don't want to go in depth, and this is a numerical which I am leaving, and this is the second problem. So just we want to have the concepts because of the less time. So now once we say the design of well, कौन सा well, deep या shallow? That is a deep well, okay? So deep wells in rocky or consolidated formations are simple to design. अगर rock है तो बहुत आसान है, because we don't need to provide screen, और जब screen नहीं provide कर रहे तो we don't require gravel filter to hold that formation, okay? लेकिन जब deep wells we provide in alluvial soils like in Lahore, fine sand या sand aquifers, so they are more complicated as they require screens and also the gravel filter. उसके साथ फिर gravel filter देना पड़ता है. An improper design of screen may result in reduced discharge. पानी कम आएगा. A good design should have optimum discharge, minimum drawdown, and long life. Now here you can see that a drilling process of the deep well through percussion method, here through rotary method, this is also through percussion method, and these are the drilling processes are going on. Now what we have to design in case of the deep wells, तो टॉपिक क्या है, elements to be designed in case of deep wells. So जब हम बात करते हैं कि deep well डिज़ाइन करना है तो हमने कितनी चीज़ें डिज़ाइन करनी है, 5 things. What are those? Number 1, diameter of the well. ये well का diameter क्या होना चाहिए, okay? The second, what should be the depth of the well? What should be the borehole diameter? ये bore कितना करना है, okay? And we should design the well screen. अगर हम alluvial soils में deep well provide कर रहे हैं तो हमें screen भी डिज़ाइन करनी है. तो screen की क्या है, इसकी screen की length कितनी होगी, यहाँ से लेकर यहाँ तक. This is the length of screen. Slot size of the screen, ये screen का size क्या होना चाहिए. And the shape of the opening and percentage open area of the screen. So this is all design of the well screen. And number 5, gravel pack design. अब इसके इर्द गिर्द हमने क्या gravel pack देना है if required. अच्छा, ये जो figure है of a deep well and tube well लगा हुआ है, तो ये कौन सा pump लगा हुआ है? Which type of pump is installed here? जी भाई. Which type of pump is being installed here? Have you studied in fluid mechanics too?
Sir, turbine.
Yes, it is turbine pump. So it is the electric motor and there is a long vertical shaft, and you know this is the pump and it is a multi-stage pump. There are so many impellers. So this mechanical energy is transferred through this vertical shaft, है ना? अच्छा, तो इसके साथ ये screen है, and around the screen what we have provided this gravel filter, as the fines should not, you know, move from here and they should enter here. They should not enter into the pump. अगर ये फाइन्स यहाँ से रिमूव होने शुरू हो जाएंगे तो फिर क्या होगा, इट विल कॉज पाइपिंग and you know the collapse of this material. जब तो वो नहीं होना चाहिए, है ना, फाइन्स नहीं निकलनी चाहिए. So now we will design these all 5 parameters. Well diameter, भाई अगर आप डिस्चार्ज की इक्वेशन देखें तो डिस्चार्ज इज इनवर्सली प्रोपोर्शनल टू लॉग ऑफ R over RW. R क्या है, रेडियस ऑफ इन्फ्लुएंस, RW रेडियस ऑफ वेल. तो ये इससे प्रोपोर्शनल है, इनवर्सली प्रोपोर्शनल है. सो इंक्रीज इन वेल डायमीटर इंक्रीजेज डिस्चार्ज वेरी लिटिल, लेकिन ये इंक्रीज बहुत थोड़ी होती है ना, बट मोर ड्रिलिंग कॉस्ट. सो अगर हम बड़ा diameter रखेंगे, its drilling cost would be more. Hence, well diameter is fixed on the basis of size of the pump. भाई क्या size है pump का, उसकी base पे, which is placed inside with proper clearance of 2 inches. 2 inch clearance रख लेते हैं. For economy, the well diameter may be reduced below the pump setting. Pump setting से नीचे हम diameter और कम कर सकते हैं. Anyway, this is the table 10.1. Which we can use for selecting the well diameter. हमारा डिस्चार्ज कितना है पंप का वो हम यहाँ से देखेंगे. It is given in Q6, maybe less than 0.22 Q6 है, या ये वैल्यू है 1.8 से 2.9 Q6 या 4 Q6 का पंप है. तो साइज ऑफ द पंप बाउल जो है वो 14 इंच है और साइज ऑफ वेल केसिंग वो इससे तकरीबन 2 इंच बड़ी रखनी पड़ती है. सो इट इज़ 14 इंच, इट शुड बी 16 इंच से लेकर 20 इंच तक हो सकती है. सो दिस इज़ हाउ वी कैन सेलेक्ट द साइज ऑफ द वेल केसिंग. ठीक है, विच इज़ द वेल डायमीटर. क्योंकि क्लियर है बात. सो हाउ वी विल डिसाइड द डायमीटर ऑफ द वेल एज ए फंक्शन ऑफ डिस्चार्ज ऑफ दी पंप. ठीक है. अच्छा, अब वेल डेप्थ निकालनी है तो वेल डेप्थ किस पे डिपेंड करेगी. वेल डेप्थ हम प्रोवाइड करते हैं यूजुअली अप टू दी बॉटम ऑफ दी एक्विफर. कोशिश करते हैं कि पूरी एक्विफर कवर हो जाए नीचे तक, where aquifer thickness is too large, लेकिन अगर बहुत ही ज़्यादा aquifer thickness, then we will not go up to that depth. फिर हम क्या करेंगे, हम कंप्यूट करेंगे लेंथ फॉर द रिक्वायर्ड डिस्चार्ज, जितनी चाहिए उतनी कर लेंगे, ठीक है. सो नाउ द नेक्स्ट इज बोर होल डायामीटर. वो ये डायामीटर है जो हम बोर कर रहे हैं. तो बोर होल डायामीटर कितना होना चाहिए, जो ये केसिंग पाइप का डायामीटर है, प्लस द थिकनेस ट्वाइस ऑफ द थिकनेस ऑफ द पाइप, एंड प्लस द थिकनेस ऑफ द ट्वाइस द थिकनेस ऑफ द this gravel filter. So that should be the bore hole diameter. जो बोर हमने करना है, ड्रिल करना है, वो उसका डायमीटर ये होगा. So bore hole diameter is bigger than the well diameter. और कितना होगा, well diameter plus twice the thickness of casing pipe plus twice the thickness of gravel pack. Is it clear? So for installing a tube well या deep well, what should be the diameter of the bore hole? वो कितना करना है हमने diameter, वो इतना करना है ना, जितना well का डाया है plus twice thickness of casing pipe plus twice of thickness of gravel pack. और gravel pack की कितनी thickness होती है वो that we will discuss maybe after 5 minutes. Well screen. So if you will see, where is, yeah, this is the screen pipe. Maybe it has this much diameter, है ना. ये सारे का सारा यहाँ से लेकर यहाँ पे screen pipe है, और ये this is how the screens are shown. So this is the outer side of the screen. यहाँ पे भी वैसे ही screen बनी होगी, है ना. ये मैंने बनाई नहीं है, तो ये यूं करके ना ये स्क्रीन है. व्हाट इज द शेप ऑफ दिस स्क्रीन, दिस वी शेप्ड. और क्या हो रहा है इसके एरिया को, वंस द वाटर मूव्स इनसाइड, सो इट्स एरिया ऑफ फ्लो इंक्रीजेस. व्हाट इज द पर्पस, इफ सम फाइन पार्टिकल हैज एंटर्ड, इट शुड नॉट स्टिक और क्लॉग इनसाइड द स्क्रीन, बल्कि वो निकल जाए. ओके. So this is V-shaped slots. इसकी slot किस shape की हैं, V-shape की. तो इधर से भी होंगी, from all around the pipe there is V-shaped screen. Now the question is what should be the, जब हम well screen की बात करते हैं डिज़ाइन की, तो how many things we have to design. कि स्क्रीन की लेंथ कितनी होगी, स्क्रीन की slot opening कितनी होगी, और स्क्रीन का डायमीटर कितना होगा. Okay, that these three things we have to design. स्क्रीन लेंथ कैसे डिजाइन करनी है, अगर तो होमोजीनियस आर्टिजन एक्विफर है. आर्टिजन मीन्स, व्हाट डू यू मीन बाय आर्टिजन एक्विफर, कन्फाइंड एक्विफर. अगर कन्फाइंड एक्विफर है तो स्क्रीन की जो लेंथ होगी, दिस इज द स्क्रीन लेंथ, it should be 70 to 80% of aquifer thickness. जो thickness है aquifer की, उसका 70 से 80% ले लेंगे as the length of screen. And screen has to occupy the bottom portion. ऊपर से खाली रख, नीचे से हम शुरू करेंगे. हाँ, अगर कोई homogeneous unconfined aquifer है तो फिर स्क्रीन की लेंथ कितनी रखते हैं, 33 से 50% of aquifer thickness. Okay. दिस इज अनकन्फाइंड एक्विफर. नाउ स्क्रीन की लेंथ तो डिसाइड हो गई, 70 से 80% ऑफ कन्फाइंड की और 33 से 50% ऑफ अनकन्फाइंड एक्विफर. और नाउ द नेक्स्ट इज स्क्रीन स्लॉट ओपनिंग. ये ओपनिंग कितनी रखनी है, सो बेस्ट ओपनिंग इज वी शेप्ड. ये वी शेप्ड की है. इट फैसिलिटेट्स द पार्टिकल्स टू मूव इनटू द वेल विदाउट क्लॉगिंग. क्लॉगिंग नहीं होती, ठीक है ना. इट इज मेड बाय वाइंडिंग कोल्ड ड्रॉन वायर अप्रोक्सीमेटली ट्रायंगुलर इन सेक्शन अराउंड ए सिलेंड्रिकल फ्रेम ऑफ रॉड्स. रॉड्स का फ्रेम बनाएंगे और उस पर हम ये वाइंड कर देंगे. सो लाइक दैट, तो ये बन जाएगी जी. हाँ, अदर आर सिंपल rectangular slot cut in PVC pipe, fiberglass pipes, steel pipes, etc. For wells without gravel filter, the size of the slot opening should be 30 to 50% retaining sand. If we are not providing, the gravel filter, वो कहाँ नहीं चाहिए, वो नहीं चाहिए in the rocky areas, okay? लेकिन अगर alluvial है तो then वो gravel filter we have to provide. And for gravel pack material, slot size is kept 90% retained material. जो भी 90% retained material होगा, तो जो screen size जो होगा वो होगा 90% of the retained material. Okay. And this is the gradation curve for formation material. जहाँ हमने वेल लगा रहे हैं उस जगह का ये gradation curve है. ये particle size है in maybe millimeters or in inches. Okay. And so इसका 90% फाइनल यहाँ पे है, ठीक? So this is the gradation curve for gravel pack material. वो मोटा होगा ना तो उसका डाया बड़ा है. And this is the gradation curve. ये जो 90% पे जो size होगा of the gravel pack material, उस वो value जो होगी, that would be the screen opening. Is it clear? And if we are providing, in a rocky formation deep well provide कर रहे हैं, तो slot की opening कितनी रखनी है? 30 to 50% of retaining sand. Suppose this is the retaining sand है, तो इसकी ये 30 से 50% any value whatever is the diameter is coming, तो वो diameter we will keep this diameter. अच्छा जी, now the thing is screen diameter. Screen diameter में कैसे select करना है कि जो velocity of flow है through the screen, it should not be more than 0.1 feet per second. यहाँ से velocity जो होगी, तो ये हम कैसे निकालेंगे? Discharge is equal to area into velocity. So 2 pi r is the radius of the screen, 2 pi r is the circumference of the screen. So L is the length of the screen, and P is the the percentage of open area into the velocity in the screen, which should be 0.1 feet per second. So using this equation, one can decide what should be the screen diameter. Here in table 10.2, the nominal screen size is given. Our intake area per linear foot of screen, ये slot मुख्तलिफ जो है ना नंबर दिए हुए हैं, तो वहाँ से we can select. But anyway, this is the basic concept. These are some figures of the screens, maybe steel screens, yeah, PVC screens which we provide, and the water enters from these screens. Now the last thing is the design of gravel pack, जो हमने gravel filter material देना है, और ये हम कहाँ चाहिए? Only when we are providing a deep well in which aquifer? In alluvium aquifer, okay? Not in the rocky foundations. So gravel pack becomes necessary when formation consists of fine यूनिफॉर्म सैंड और अलूवियम, तो ये देना ही देना है, ठीक है? उसके लिए हम क्या करेंगे? प्लॉट ग्रेडेशन कर्व फॉर द फाइनेस्ट मटेरियल एक्विफर लेयर लाइक दिस वी हैव प्लॉटेड. So we have to plot this gradation curve. Multiply 70% size of the aquifer material with 4 and 9. Now the 70% size is here, okay? And this is that size in inches, and we will multiply with 4 and also with 9 and with 6. Use for for fine uniform. If this is uniform sand, we will use 4. Use 6 for coarse non-uniform sand with no silt. Silt नहीं है और जनाब बस sand है और uniform भी नहीं है, तो 6 से multiply करेंगे. Use 7 for sand of highly non-uniform gradation. है sand लेकिन बहुत ज़्यादा उसमें वेरिएशन है, तो मींस फाइन सैंड, कोर्स, मीडियम सैंड एंड कोर्स सैंड, तो आप 7 यूज़ करेंगे. तो ये 70% पे जो डायमीटर है उसको 7 से मल्टीप्लाई कर लेंगे. उसके बाद क्या करेंगे, प्लेस द रिजल्ट ऑफ मल्टीप्लिकेशन ऑन द सेम ग्राफ पेपर which gives the first point on the sieve analysis curve of the gravel pack material. Now ये जो है, दिस इज दी फॉर द ग्रेवल पैक मटेरियल. ओके, और वो जो हमने 70% से अगर वो जो थी वैल्यू, वहाँ से हम देखेंगे. Draw through this initial point a smooth curve parallel to the sieve analysis curve for formation material. अब ये 70% पे जो डायमीटर निकला है उसको हम 4 या 6 या 7 से मल्टीप्लाई करेंगे एंड वी विल गो बैक कि ये 70% पे वो फिर हमें डायमीटर मिल जाएगा. यहाँ पे जो हमें पॉइंट मिलेगा तो वी विल प्लॉट दिस कर्व पैरेलल टू द फॉर्मेशन मटेरियल कर्व. ये हमारा ग्रेडेशन कर्व आ जाएगा. तो देन दिस इज द मटेरियल या ग्रेडेशन फॉर द ग्रेवल फिल्टर. तो हमें पता चल जाएगा जी ये ग्रेवल फिल्टर का साइज इधर से लेकर यहाँ तक होना चाहिए. एंड दिस मटेरियल साइड शुड बी 100% फाइनर. ये मतलब हर 10% के बाद वी कैन कंप्यूट द वैल्यूज के व्हाट शुड बी द डायमीटर. एंड दिस इज द डिज़ाइन ऑफ द ग्रेवल filter. Now how much should be the thickness of the gravel filter? 3 inches to 8 inches. So ये जो gravel filter है इसकी thickness 3 इंच से लेकर 8 इंच तक हो सकती है. Material की gradation क्या होगी? That would be this one. तो हमने ये लाइन कैसे लगानी है? 70% पे जो डायमीटर फॉर्मेशन मटेरियल का आएगा उसको इधर वी हैव टू मल्टीप्लाई बाय 4, 6 और 7. तो फिर वहीं पे हम वो वैल्यू पिक कर लेंगे एंड देन वी विल ड्रॉ ए कर्व पैरेलल टू द फॉर्मेशन मटेरियल कर्व. एंड दिस इज द ग्रेडेशन फॉर gravel pack material. And with this we have designed the main parameters of the well. तो ये थोड़े पता होने चाहिए थे. And with that we have finished this lecture. So do you have any questions? जी भाई. Excuse me.
सर हमारे से क्वेश्चन था सर.
हाँ जी.
सर ये
वेलकम जी.
डिजाइन ऑफ कैनाल में सर काफी ज्यादा रिलेशन से फार्मूले हैं सर, वो पेपर में प्रोवाइड किए जाएंगे?
एक्चुअली वो मिड सेमेस्टर में आएगा ना आपका, मिड सेमेस्टर के पेपर में. तो
जी.
अच्छी बात तो ये है कि आप याद कर लें फार्मूले. ठीक है ना, आपको याद होने चाहिए. जो जैसे बेसिक फार्मूले हैं वो तो आपको पता होने चाहिए. हाँ, कोई बहुत बड़ा फार्मूला है तो दैट कैन बी गिवन, वेरी वेरी बिग फार्मूला.
सर जो रेजिम थ्योरीज में है उसमें मतलब हर एक रिलेशन दूसरे से अलग है और कांस्टेंट है काफ़ी. यस.
तो वो देखो सर, वो फॉर्मूला मतलब नहीं, जैसे बेसिक लेसिस रेजिम थ्योरी है या जो कैनेडी थ्योरी है उसके तो बड़े आसान है ना, छोटे छोटे फार्मूले. लेकिन अगर आप इफ़ यू विल ट्राई टू रिमेंबर फार्मूला इन सिस्टम इंटरनेशनल एंड इन इंग्लिश सिस्टम बोथ, देन डेफिनेटली यू विल मेट विद ए मैस. वो मिक्स हो जाएंगे और वो डिफ़िकल्ट. तो एक सिस्टम में याद करें, पहली बात तो ये है. एनी सिस्टम विच यू लाइक, तो उसमें आप जहन में रखें, दूसरे सिस्टम को बिल्कुल भूल जाएं, और अगर आपका न्यूमेरिकल आता है कन्वर्ट इट इन दैट सिस्टम यूनिट्स एंड देन यू सॉल्व इट। ठीक है ना? जैसे हमने मेरे ख्याल है ज़्यादा किस में किए हैं, मीट्रिक में भी हैं वैसे तो, और इंग्लिश में भी है ना?
यस सर।
अच्छा, बाकी ये कि जो बहुत बड़े फार्मूले हैं वो ऑफ कोर्स आपको आइडिया ज़रूर होना चाहिए, तो अगर बड़ा फार्मूला कहीं आता है तो वो दे देंगे।
ओके सर।
ठीक है ना?
यस।
लेकिन बेसिक जो फार्मूले हैं वो आने चाहिए, मतलब ये नहीं दिया जाएगा कि जी डिस्चार्ज इज इक्वल टू एरिया इनटू वेलोसिटी।
ओके सर।
वो तो नहीं ना देना चाहिए।
जी जी।
तो और कोई चीज़ है? So wish you best of luck ji. So we have finished this course of irrigation engineering and unfortunately सारे का सारा ऑनलाइन था।
सर
जी
सर डेट शीट पर कुछ फाइनल डिसीजन हुए?
नहीं, एक्चुअली डेट शीट ये हुई है कि वो अब देर बहुत हो गई है। मैंने कल बात की थी लेकिन वो 1 हफ्ते से ज़्यादा तो हम भेज चुके हैं वो टू कंट्रोलर ऑफ एग्जामिनेशन। उसी वक्त हो जाना था जब पहले पहले था ना, तो मैंने मेल भी कर दी थी चेयरमैन साहब को कि वो ठीक है कर दें, कोई मसला नहीं। अभी वो भेजा जा चुका है ना टू दी कंट्रोल ऑफ एग्जामिनेशन।
सर देख लें अगर नोटिफिकेशन रिवाइज हो सकता है। एक्चुअली उस वक्त हमें किसी ने बताया ही नहीं है कि आपकी तरफ से इजाज़त मिल गई है, अदरवाइज हम लोग वो कर लेते।
अभी ये है कि हमें वाइस चांसलर से पूछना पड़ेगा, एंड इफ ही अलाउज अस देन आई थिंक वी कैन डू। ठीक है, so I will try to contact today with the vice chancellor this issue.
Okay sir, thank you sir, thank you.
Or anything else? चलो जी, that's good कि जी course is covered today. So okay ji, then thank you very much.